So the last part, we started to talk about routing protocols, dynamic routing protocols. So we talked about RIP and we talked about OSPF. So we stopped at this slide where we talked about hierarchical OSPF. And the main reason for hierarchical OSPF was the fact that the link state flooding needs to be more scalable to avoid the overhead resulting from flooding all these link states to the entire network. So to mitigate this, OSPF defines the hierarchical concept where we define the concept of areas. So the link state advertisement is flooded within an area. So we have the backbone, and this backbone is connected with different areas. So this actually divides these routers into multiple designated routers. Each one has a specific role and functionality. So we have area border routers. The area border router is the interface between the area and the backbone. And this router actually conveys the link state summarization to the different areas. And we have this backbone router, and we have the boundary router. This boundary router is responsible for connecting the entire autonomous system to other autonomous systems. So this router should in fact have border gateway protocol, this one, okay, and should facilitate the connection between this network and other autonomous systems. And we have actually the backbone router. The backbone is just a special area which kind of connects to all the other areas. So this is the backbone area. All the routers inside it is called backbone routers. So these are the definitions. So we have two levels, and again, these two levels is to enhance the scalability for OSPF, particularly related to link state advertisement, which is only valid or only confined within an area. And each node has detailed area topology, only know the direction or shortest path to this to any other router in this area only. Okay. And there is the area border router, which summarizes these distances to the network in its own area. So the area border router interfaces this area with the backbone. Okay. And the backbone router interfaces the entire network to other autonomous systems. And there is the boundary router is the one that interfaces all this network to other autonomous systems. Backbone routers are routers that are limited to the backbone area. And the backbone area is a special case area which connects all these other areas together. So border gateway protocol, as we said, is the exterior routing protocol, is the predominant one. It's the only example when it comes to exterior routing protocols. And border gateway protocol is responsible for the interaction between autonomous systems. So the border gateway, the way it works is slightly different from OSPF and RIP. So this one is predominant by the policy, as we said before. So when it comes to autonomous systems, when they interact together, the most important thing is is the service level agreements, because as we said, autonomous system is a domain which is controlled by a single authority or one owner or one service provider. So for example, Ooredoo, they have their own autonomous system. Vodafone, they have their own autonomous system, and so on and so forth. So to facilitate the interaction between multiple authorities, more often than not, we care more about the policy or the regulations or the legal bindings that controls this kind of communication. So when it comes to communication between these internet service providers, they have very detailed service level agreement that lists all aspects related to quality of service, what is the maximum throughput, what is the expected delay, things like that. And border gateway protocol is the one that glues all these autonomous systems together. Border gateway provides the means to have exterior border gateway protocol. This is the one which is responsible for facilitating the highway communication between the autonomous systems. So if you have two autonomous systems like this, as we said, there is like some kind of a highway between them, okay? And there is, of course, there is a boundary router on both sides. So exterior border gateway protocol is the one that's established between these two autonomous systems across the highway. The interior border gateway protocol is the one that works inside each autonomous system to, again, communicate the reachability of the other autonomous systems to the internal routers. Because internal routers as well, of course, any internal router here should have some connectivity information to a destination here, which is connected through this autonomous system, right? So the part of the border gateway which is responsible for communicating this reachability to the internal routers here is what we call a interior border gateway protocol. Okay, so we'll see how this is done. Based on this information, we determine the good routes to other networks based on reachability information and policy. And as we see, what is the sequence now when we have certain policies and we have also other metrics related to shortest path? So which one dominates? So what is the procedure if we were to have a policy and also shortest path? As we talked last time, we talked about hot potato routing, where if the policy allows, then we go with the shortest path. So shortest path comes as a criterion after we apply the policy. If the policy says yes, we can communicate to both autonomous systems, or to 3 or to 4 autonomous systems, then we differentiate between these autonomous systems based on the shortest path. Okay. One important thing we should know here is that the border gateway protocol establishes a session between these border gateway routers across the highway, and this session actually uses TCP connection. So it's a semi-permanent session that gets assigned. This is the only example where we talked about TCP session being used to exchange distances between the autonomous systems. Because we talked about OSPF and we talked about RIP, and both of them uses some kind of UDP connection, or actually it uses directly IP for exchanging the link state or for exchanging the distant vectors. But here in BGP, because it facilitates this inter-autonomous system communication, we use TCP connection for exchanging the distances or the reachability information between these autonomous systems. واضح كده؟ So for example, when AS3 advertises a prefix to AS1, advertises a prefix about some networks here, okay, which are reachable to AS1 through AS3. So what that means is, in AS3 promises it will forward these datagram towards that prefix. So if AS1 wants to send datagrams to one of the destination networks here, it sends it first to AS3, and AS3 will take care of this. So in order for AS1 to get this reachability information, it needs to have these distances communicated through AS3 and through the TCP connection to AS1. Then AS1 will exchange this information to the internal routers through, as we said, IBGP, and these routers will then have the information how to reach these final destinations. Of course, when it comes to exchanging the distances between the autonomous systems, we use route summarization. right? So each of these autonomous systems, as we said before, they get assigned a range of IP. صح كده? So if we were to send reachability information to autonomous system 1, AS3 will summarize all these groups of networks into one or very few reachability information based on the prefix. And the prefix here defines a range of IP address, which could be very, very large, that summarizes all the IPs in these networks. And it exchanged this with AS1, and AS1 will exchange it to internal routers and so on. You had a question?
I think you answered some of my question. I wanted to also know the prefix we're sending. Why does AS1 need to know the networks for
Here?
Yeah.
Because this is part of the internet. So
to continue reaching.
of course, yeah. So imagine that this AS1 مثلا is Uridu. Okay, so Uridu wants to route your traffic to Europe. So it has to go through Orange, مثلا, in Europe, right? In order to reach to the other networks. So that's what typically happens because of the fact that the internet is by default a decentralized architecture, right?
Also, the edge routers and each autonomous system are different from the edge routers within that autonomous, are different from the other routers within that autonomous system.
Yeah, the main difference is that these routers, they also run exterior border gateway protocols.
Right.
Okay? Because interior border gateway protocol should run on every router. But the exterior one facilitates the exchange of distances across this highway.
It's different hardware or just like...
No, it's just a software. It's just a process. A process, yeah. Okay? So this is how it looks like actually. As we said, we have the exterior border gateway, which is this one. So this is a TCP session, and the interior border gateway protocol session, which is again runs on every router to convey or to propagate the reachability information from other autonomous systems to the internal routers. Because at the end of the day, router 1D, for example, needs to have some information about how to reach networks here, right? So that happens through the prefix or route summarization that gets conveyed to router 1D through border gateway protocol. And as we said, routing table in every router aggregates route entries from all these protocols, okay? It receives information from OSPF, possibly from REP, possibly from BGP. So technically, the routing table gets updated from multiple dynamic routing protocols as needed. Okay? Typically, مثلا, inside the autonomous system, each router propagates the information in the routing table manually from OSPF and BGP, or from REP and BGP, or from IGRP and BGP. Okay? So the information from both protocols, they get reflected into the routing table. تمام كده? So using exterior border gateway session between 3A and autonomous and 1C, this one, okay? AS3 sends the prefix reachability information to AS1. The prefix هنا, again, prefix represents the range of IPs, okay, which can be reachable through AS3. And it will send this information to AS1. So 1C can then use the internal, so 1C here uses the interior border gateway protocol to exchange this reachability information to the internal routers. ماشي كده؟ Again through TCP session برضه. يعني the interior border gateway sessions, these are also TCP connections, right? So mainly BGP is the one that uses TCP for exchanging distance.
What do we gain from using TCP? Because other protocols use UDP.
True, yes. Border gateway uses TCP because it uses semi-permanent session, okay? And it needs some reliability to exchange this information, okay? So this is mainly why it uses TCP. So 1B can then re-advertise new reachability to AS2 and so on. That's how the information propagates through the network. When router learns of new prefixes, it creates entry for the prefix into the forwarding table, as we said. So both OSPF or REP, they reflect this information, and BGP, they reflect to the routing table. One thing that we should keep in mind here is that unlike dynamic routing protocols, which they rely mainly on next hop, or the prefix or the network address, and the next hop, which is the output interface. So we need to know that the router needs to know that when it tries to send to that particular destination address, whether it's a network address or a host address, it needs to go through this output interface. That's all. For BGP, it uses, in addition to that, it uses attributes. This is very important, but it uses attributes. So we have attributes, and these attributes could be the AS path. Here, the AS path, remember, the AS path contains all the autonomous systems, not the final one, all the autonomous systems through which this prefix advertisement has passed. So I may get from autonomous system مثلا X that I can reach to prefix whatever, so prefix X, which is again range of IP address, through AS3, AS7, AS10. All this is maintained in the AS path, not just the final one. Okay? So we have to maintain the AS path completely. ماشي كده؟ So it's not only the next hop and that's it. So we have to maintain the entire path of the autonomous systems. Why? Why do we do this for BGP? Unlike other dynamic routing protocols, which rely only on the shortest path for delivering the datagram, here we have to really watch for policies and regulations. So maintaining the S path will always facilitate any router to make decision based on policy, because the router or the autonomous system needs to check its own policy with all these autonomous systems in order to be able to make a decision. Okay? So, for example, if I have reachability information to that prefix coming from two autonomous systems, one that has AS path AS مثلا 8 and AS 10, okay, to the same prefix. Okay, so in that case, the router will make a decision first and foremost based on the policy. So it will say, so let me check my policy with every single autonomous system in this AS passes. So I may get the reachability information from two different sources, right? صح كده? Because the internet is decentralized. So I may get reachability information to the same prefix through different autonomous systems. So first, it checks its own policy with all the autonomous systems in that path, and this is very important. Okay? So if the policy says that I cannot, for example, forward datagrams through AS8 for whatever reason, then I don't have a choice. Then I have to select this path. So the policy always dominates. Okay? If and only if I have service level agreement with all these autonomous systems in the AS path, then the next step comes where we check by shortest path. Then we check the shortest path. And of course, in that case, I may say, oh, okay, so here there is only two autonomous systems where that one will have 3 or 4. So it's better for me to select the shortest one. Okay? So, and of course, the attributes also contains the next hop. And the next hop here indicates the specific internal autonomous system router to next hop, which in that case is the boundary router. It's actually the boundary router. Okay? So just to visualize. So this one is one autonomous system, and it has a router here, and it has two boundary routers. One connects this autonomous system to another autonomous system, مثلا let's say 10, and one connects it to autonomous system, مثلا 7. Okay, so I received reachability information from here and from here. Okay, so I received for the same prefix. Okay, so all this information will propagate and will reach to this router. So this router now needs to make a decision. So the first thing it checks is that is the AS path here, and there is AS path here. Do I have a policy? Do I have service level agreements with all the autonomous systems in all these paths? If the answer is yes, then okay, so policy says I can do it to either AS path. Okay? So then let me check if the AS path coming here is shorter compared to this. If they are the same, then I say, okay, so let me check the next hop here and the next hop here. Okay? So this is the internal, this is the hot potato routing where internally we say, okay, so the cost to reach to this boundary router that will allow me to reach to AS10 will have a cost of 3. But now here, to reach to AS7, I have a cost of 10. Okay? So in that case, I should go here. Okay? So this is the logic that we need to apply. So we mainly use the policy-based routing or hot potato routing if the policy allows us to go through multiple autonomous systems. Then we select the one with the closest next hop or the closest boundary router. Any questions so far? So the router may learn about more than one route. This is what we've been discussing to destination AS. It selects based on first, local preference, اللي هي policy decision. If the policy is the same for both, then we select the shortest AS path. Okay, shortest AS path first. And if both of them are the same, then we go with the closest next hub, the closest boundary router. Okay. Or if there is any additional criteria, let's say مثلا security. Okay, so there is AS path which gets me to autonomous system X, and I have, I know that this path مثلا has more security, something like that, or quality of service, some additional criteria other than these. ماشي كده؟ So there is the concept of dual homing, and the concept of dual homing is well known to service providers, where مثلا destination like X is actually connected to 2 different service providers. Okay, we call this dual homing. يعني of course مثلا Qatar University has dual homing with both Ooredoo and Vodafone مثلا. Okay, but what is the implication of this on the routing? There is an implication for this on the autonomous system or the inter-autonomous system routing. So A, B, and C are network providers. X, Y, and Z are customers, like Qatar University, like any customer. So X is dual homed and attached to 2 networks at the same time. So in that case, one thing we should do, or we should take care of, is that X should not advertise any routing coming from B to C. Why? To avoid loops, يعني. Right? To avoid the concept of loops, especially that B and C are connected together. So in dual homing, we have to keep in mind this looping issues, and usually in that case, we avoid trying to re-advertise the routes, because X is also, it has its own network, right? So Qatar University has its own network, and if it does not take that into consideration, automatically it forwards this advertisement information to C. So in that case, we create the concept of loops. بينما X should use the dual homing for what? X uses dual homing, as we said before, for one of two scenarios. If my connectivity to one of these service providers is affected, then I switch to the other one. If both of them are working, I use that for load balancing. Okay? So I may create some rules that, okay, so I have مثلا some reachability information that comes from B and C. Okay? I select مثلا certain prefixes to be routed through B and certain prefixes to be routed through C. So this way I can do some load balancing. Okay? Or if one of them is affected, then I switch to the other one, which is the concept of backup or fault tolerance. I use it for fault tolerance. But definitely I would want to avoid this concept of looping. So that's something that we need to pay attention to. Okay? So A advertises path AW, X advertises A advertises path AW to B, okay? And B advertises path BAW to X, okay? Should B advertise the path, this is what we've been saying. Should B advertise path BAW to C as well? So that's also, this will also create some kind of looping. So in that case, we try to avoid this concept of looping. So one of the issues that we have to pay attention to for inter-autonomous system protocols is the concept of looping through the autonomous systems. ماشي كده؟ So that's the man.
Yeah, here.
Okay.
Why I understand you said there's looping.
Okay.
Why can't it just?
Why A?
So basically, you said there can be looping if we advertise BAW to C, right?
Right.
Why don't they know, like, not to loop, like the router?
Why? How? Sorry?
How come they don't know? Like, how come not all the routers?
لا, this is through rules يعني. هو يعني this whole thing will be documented in the service level agreements. So it's actually by rules in that case. It's not by the fact that they will detect it automatically or something like this. So they know this. Sometimes because B gets no revenue مثلا from for routing this particular traffic to C. يعني sometimes this مثلا this connection between the autonomous systems is only to facilitate the communication, but that doesn't mean that خد بالك B and C are peers in that case. So B is not a customer to C and C is not a customer to B. So they don't exchange any monetary revenue. Okay? But why do we have this connection? It's only to facilitate communication. So we can use this to مثلا route to other autonomous systems in that direction. Okay? But definitely I would want to avoid loops in that case. Or I don't get any money if I do this advertisement to C. When do I use this connection? Only if I have مثلا autonomous systems in this direction, then I can route through B, through C, and then to other customers. So in that case, B and C, they have mutual benefit to serve each other, but that doesn't mean that any one of them gets revenue from each other. Okay? So this is only for facilitating the communication and not for exchanging money, because they are not customers to each other. So usually A, B, and C, by the way, are بنسميهم ايه tier 2 or tier 1 internet service providers. If we remember, we discussed this in the very first beginning of the course. So A, B, and C are in that case tier 2 or tier 1 مثلا. يعني if we talk about Ooredoo, Vodafone, Orange, these are tier 2. Or if you talk about AT&T, Verizon, these are tier 1 service providers. So when these service providers in the same tier, they connect together, is only to facilitate the communication and not to exchange any revenue or anyone is customer to each other. Okay? But each one of these, they have customers in the other tier. That's what typically happens in the decentralized architecture of the internet. Okay? The only issue that we need to... So this is like a summary. So why different intra and inter autonomous system routing? As we said before, one thing is because of the policy. Sometimes the interconnection between the autonomous systems is actually dominated by the policy and not by shortest path and metrics and what we have discussed before. Also for scalability. If we have hierarchical routing using BGP, then we can increase the scalability because to communicate the reachability of autonomous systems to other autonomous systems, we always rely on route summarization. So we can summarize prefixes that facilitate the communication with a large network using one entry in the routing table. So this way we can increase scalability and, of course, the performance. So the different hierarchy or the different layers of the routing, they care about different things. So intra-autonomous system, which is the interior routing protocols like OSPF and REP, they can focus on performance in terms of shortest path. Okay? بينما the inter-autonomous system routing or the BGP, it cares more about the policy and the service level agreements between the autonomous systems. Okay? تمام كده؟ So
Can you go back to slide?
طيب. So this is the end of this part, and